So now let's go to page 1. Let's read note 1. The voltage divider circuit is the most commonly used bipolar junction transistor biasing circuit. And it's popular because it is beta independent. And what that means is that beta is my HFE, right? And with regular transistors, transistors get hot, or they may be in an environment where there's a lot of heat. So as there's heat around a transistor circuit, that transistor may get warm, and its HFE value, which is around 150, 175, 200, might change in value. It might become from 200, it might change to 220 or 230. And when that changes, okay, your Q point is going to shift. It's no longer going to be where you want it to be with temperature. And so because it shifts, then what happens is, if you're using this transistor circuit or one that has the Q point shifting, what might happen is that if it is in an amplifier circuit, you might get distortion coming out of the amplifier. Your sound might become fuzzy, okay? Your signal might lose its integrity. And so we're going to talk about that more when we talk about amplifier circuits, but that's the idea. So that is why, because of the fact that this circuit is called beta independent, meaning that even with fluctuations in temperature, your Q point does not change much on the DC load line. It just stays where you calculated it regularly with your parameters, okay? And so that's why this voltage divider circuit is called a universal biasing circuit. It is the most popular one. Okay, so you don't have to draw this, but I'm going to draw figure 1, where I'm starting out with my R1, R2 that you can see, which is the voltage divider circuit. So on the left side, you see R1 and R2, VCC. And what am I doing now? I'm connecting a transistor to the voltage divider. Do you see that? Figure 1? So there's my voltage divider, just like all the other circuits that I drew there. R1, R2 is the voltage divider. Now you know why it's called a voltage divider circuit, right? So if I ask you next Friday, I was going to have a quiz next Friday, but I can't anymore because there's no class next Friday, no lab next Friday for those who have labs on Friday. So it's a day off for you guys, okay? So this circuit is the voltage divider circuit, R1, R2. Previously, I've worked with circuits where there has been an RC, right? I've worked with circuits with RC. RC is the resistor that is connected to, what does the C stand for? The collector. This is something new. I have a resistor which is labeled RE, which is connected to the emitter. This is the thing that does the trick. By having an RE, what it does is that with temperature, as that Q point tries to shift, there is a push-pull that's happening. There is a resistance up here, or there is a voltage up here, there is a voltage here, and that voltage causes a push-pull, and the Q point therefore does not shift. It stays where you calculated it. So by adding an RE, it's going to maintain the Q point from moving. Okay, so figure 1 shows an NPN circuit, and figure 2 shows a PNP circuit. What is the main difference between NPN and PNP? The supply voltage. In one case it's plus VCC. In the case of a PNP, it is minus VCC. Okay, so now let's turn to page 2. What does the note at the top of page 2 say? Stiff voltage divider circuit analysis. Okay? Meaning that this is what it means. I've got R1, R2. Go back to page 1. Go back to page 1 for a second and show the double arrows. Right there. Show the double arrows. You all know what the double arrows mean, right? It is the, in this case, the transistor acts like a load to the voltage divider circuit. Remember, we talked about the cell phone acting like a load to the voltage divider. Here, it is the transistor that is acting like a load to the voltage divider circuit. And what is the size of that equivalent resistance that the transistor appears to the voltage divider? It is HFE times RE. Okay, so if I'm standing here, if I'm looking at the transistor circuit, it's going to appear like a load, which is HFE times RE. So we know that HFE typically is 150 or 180 or 200 or a big number like that, right? We've seen HFEs before in the labs. And so what this transistor circuit is going to appear to the voltage divider is the HFE value times RE. And so I take this resistance, multiply it by 200 or 180, and that's what that resistance going to appear to the voltage divider circuit. Okay?